All right. I I guess we'll have a lot of fun with this. I think this is a good idea. So here's what we got. I have an We've had an issue with our American math classes where we have like you all have seen them, the play pieces, the little colorful blocks that we use in our lessons. But they can be pretty expensive if you're gonna get the full 1,000 piece set, like how we really advise everyone get. And it gets a little difficult getting your hands onto those pieces. So we're going to be building a game to solve that problem. And you're going to be following along with me as I give it a shot. We will be using the Godot engine and Godot software. And this is going to be the first full game that I've built. Now, I have a lot of coding experience. I've worked on websites, and I've experimented with Unity in the past, like years and years ago, in C Sharp and C++, mainly C Sharp. But we're going to be having some fun just working on this project today. I'm going through a engine provided by GD Quest. Here, let me share my screen with y'all. Um, do, 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 do. All right. Let's see. Probably should have had this set up a second ago. No worries. I got it. There we go. Okay, perfect. Now, voila, over here is what we're going to be working with. This is provided by GD Quest. It's a little game that they came up with so that they can teach you how to use the program. So I'm just going to be following through it as I learn this program so that we can then use it for American Math. And I'm just going to be using this to document the process as we go through it and everything. So yeah, let's just have some fun. Uh, and I already have some coding experience, so I'm gonna be skipping through some of this stuff since I'm already pretty familiar with it. And yeah, let's just have some fun. When coding, you always use a lot of code from developers who came before you. In a moment, you'll write your first code. You'll use functions created by the Godot developers. A function is a list of instructions with an exact name. We can tell the computer to execute all the instructions in sequence with that name. When you tell the computer to execute a function, we say you call the function. To call a function, you write the exact name followed by an open and close parentheses to call the function named show. You should write show, open parentheses, close parentheses. In Godot, calling show makes something visible, like a character or item. The complementary hide function hides the entity. Once an entity is visible, calling show again doesn't have any effect. Similarly, once you hide something called hide, again doesn't change anything. Click the run button on any example below to execute the code listing. Alright, so that runs hide. In the code listing above, we write the function call hide and a new function named run to execute the code. Creating a new function, it's necessary to execute instructions in GDScript. Okay, so you run the function called run, which then runs the function code. Got it. Can you tell me about the run function? Ooh, do I want to read all this? Sure. In GDScript and like in some other languages, we must write our code inside of custom functions. You'll learn what functions are and how they work in great detail in the course. But there's a quick reading. But here's a quick look at them if you're curious. A function is a bundle of code you can execute anytime. It's a named list of instructions. To define a function, you need to write the function keyword, the function's name, parentheses, and a colon. So function, then name of the function, open close parentheses, colon, defines the function named run. You then go to the next line to write the function's body. That's the instructions of the function. Notice how each instruction starts with a leading tab character. The computer uses that to know which lines are part of the function. Throughout the course, you'll see many functions called run. Those are functions we created to give you interactive examples. I need to close this window because it was raining out, and one thing about me, I love the rain, but it just got really humid in here, so I gotta close this real quick. Okay. And let's turn this fan on. Alright, next. Function arguments. We use parentheses to call functions because you can give the function arguments inside the parentheses when calling it. Here's a sprite standing straight. If we call the function rotate 0.3 function, the character sprite turns by 0.3 radians. I'm assuming that means degrees, right? A radian is using a measurement of angle based on the surface circumference. It tends to use degrees more in our daily lives, but in computer programming, and especially games, radians are common. Interesting. An angle of 2 times pi radians corresponds to 360 degrees, and an angle of pi radians corresponds to 180 degrees. So 2 times pi and pi? But I thought pi was 3.14. We'll need to do some research into that. Function run rotate 0.3 radians. So every time you run this, it will rotate it 0.3. Cool. The 0.3 part between the parentheses is the function's argument. So I'm going to call that the content. I mean, it's probably, it might be better to call it the argument, but I like to think of it just for my own learning as the content. You have a function, which applies specific instruction. So yeah, you define the function, it runs a specific instruction, in this case, run, and then it's going to tell you the content or the specific parameters of that adjustment. So this function is going to run the rotation function of 0.3. Cool. All right. Arguments are values, numbers, bits of text, and more that change how the function behaves. Okay. Arguments let you fine-tune the effect of the function call. They can be optional at times, but functions often require arguments in order to work. For example, calling rotate without any argument will result in an error. Without an argument, Godot doesn't know how much you intend to rotate the sprite. So if you call rotate and it's like how much, you don't say, then what are we supposed to do with that? Come on, man, think. You gotta apply the function. Argument. For example, calling, yeah, I already read that. Don't worry about memorizing what arguments each function requires or accepts. As a programmer, the documentation will always be close to you for you to refer to. Finally, notice how we use a dot in the number 0.3. However, you need to use a dot like this to represent decimal numbers. You can't use commas. Have a different purpose in codes. Okay. What does the code below do? Show. It calls the function named show. It makes the entry. Yeah. It does both. It makes the entity like a game character visible. Perfect. Both answers were right. Technically, the code calls the show function, and doing so makes the game entity visible. Another example with the move underscore local underscore x. So from what I know, that's going to move the node or whatever we're manipulating along the x-axis. You can move the character to its left and right, which is the x-axis. The function takes one argument, a number of pixels, to offset the entity. The complementary function move local y makes the character move up and down along the y-axis. This is one way to move a character in a game, although we'll see more powerful ways to do this later. Function run is going to run move local, so it's going to move it 20 pixels to the right and 20 pixels up. Moved it down. Okay, so I was half right. So I know that sometimes when you're doing X and Y coordinates, like positive integers or numbers are going to move right. So that'll be, if like in this case, it moved to the right on the X-axis. But this positive number for 20, it moved it down in the Y-axis. I was expecting it to move down. So if we wanted to move up, then we would change that to negative 20, which will reverse the direction. That's how you would get it to go another way. Y move local y 20 moves the character down. Oh man, did it? I literally just explained this. With positive values, the code above moves the robot to the right and down. This is probably different than what you studied in school. In math classes, the horizontal axis points to the right, like here, but the vertical axis points up. In video games in general, and 2D computers, the vertical axis points down instead. So whenever you move something on the y-axis with a positive value, it'll move down. Voila. What is the syntax you use to call the function in general? You write its name followed by a colon. You write a value like a number followed by the operand opening of closing parentheses. You write its name followed by an opening and closing parentheses. Yeah, you do this. Woohoo! So let's all right, let's move on to the next one. Make the character visible. The robot's invisible. Call a function to bring it back. Okay, let's try this. A robot character is invisible. Call the show function to make it appear. So we're going to type in show, open parentheses, close parentheses. And I think that's all we need to do. Please call show inside the run function on line 2 and keep the tab character at the start of the line. The computer needs this to understand your code. Ooh, that's interesting. So it won't understand it if we get rid of that. That's one thing that I love that they did, because in other coding programs you would use brackets instead, like these. So yeah, it would show, I could be wrong, but yeah, it would show this, and then you would have to put whatever other functions. So if you wanted to put a hide function in here, just for example, you would have to do that. But here it's saying that it's tab, I don't want to say delineated, I'm not sure if that's the right word, but like, you use the tab to say, okay, this tab is applying to the run function above it. And I love that because it helps to keep the code organized like how I like it. And if it automatically keeps things organized, then there's no need to use the brackets. Win. So let's run this. Voila. All right, let's go on to the next. Make the robot upright. The robot has been turned negative 0.5 radians. You need to make it upright by calling the rotate function. So let's do that. Please call rotate inside the run function on line 2 and keep the tab character at the start of the line. The computer needs that to understand the code. So let's do rotate, open parentheses, then we need to do negative 0.05. Actually, no, we need to move it positive 0.5 in order to move it back. Right? Yeah. Pudding. Glad I caught that. Let's move on to the next. We'll use code created by others like we did in the previous lesson. This time, we'll solve a more complicated problem, drawing shapes. Meet the turtle. We represent you, the turtle. We created the turtle to watch as you call the functions. The turtle is a little machine that moves forward, turns, and draws lines along its path. To make it draw, you give it a list of instructions. On each code line, you call one specific function. I remember there's an iPad game I played like this a long time ago. I think when I was in middle school. Never really got into it too much, but they use the exact same turtle thing, and I'm pretty sure it had to do with coding. To make it draw, you give it a list of instructions. On each code line, you call one specific function. We prepared several functions for you. Move forward, pixels. Okay, so it's telling us the function and then the content, or the argument. Makes the turtle move forward over a given distance of pixels. Turn right makes the turtle turn clockwise on a precise amount of degrees. That's good to know. So the radians are automatically going to turn clockwise. If you want to turn counterclockwise, go into negative. Wow, never mind. If I just read a little bit more, you could also use the turn left function, where it's the same as turn right, except it turns counterclockwise. Okay, well, yeah, who cares? You'll use these functions the same way you used rotate before. The turtle draws a white line as it moves. We'll use the line to draw shapes. For example, to move the turtle 200 pixels, you would write move forward 200, and there we go. So we have the function run move forward 200. Got it. Turning left and right. The function turn left and turn right work the same. To turn 45 degrees to the right, you would write turn right 45. If we call turn right 45, the turtle turns 45 degrees to the right before moving on the next instruction. So move forward 80, turn right 45, move forward, turn left, move forward. So let's see what that looks like. Got it. So I made a little lightning bolt. Using these instructions, we can make any two-dimensional shape we like. Try to understand the example below. In the next practice, you'll use the functions we saw above to first draw a corner, then a rectangle like this one. My desktop video. Let's do this. Now y'all can hear. Okay. And the function called below, which part is the argument? This one. The turtle uses code made specifically for this app. The turtle is a little learning tool custom made for this course based on a proven code learning methodology. It's designed to teach you how to use and create functions. Please don't be surprised if writing code like turn left inside of Godot editor doesn't work. And don't worry, once you've learned the foundations, you'll see they make it faster and easier to learn Godot functions. Let's move on to the practice. You'll get to play with the turtle function and draw some shapes. Let's get into this. In this practice, we'll tell the turtle to draw a corner. The corner is made up of two lines that are 200 pixels long. The lines are connected at each end by 90 degrees or right angle. We move forward and turn right functions, and to the right draw a corner, but they're missing some arguments. Add the missing arguments so the turtle moves forward 200 pixels, turns right 90 degrees, then moves forward again 200 pixels. We added the first argument for you so the turtle can move forward 200 pixels. Let's run that to see. Oh, too few arguments, return a right call expected. So this is one of those examples where it's not even going to run the function because it doesn't have an argument inside this. So we want it to turn right 90 degrees, and then we want it to go down again another 200. So did that work? It did. Okay, you completed the practice. Stay and play around or continue the course. Let's go. Add the correct arguments to the function, move forward, turn right to draw a rectangle with a width of 200 pixels and a height of 120. So we're going to move forward 200, turn right 90 degrees. We're going to move forward 120 pixels, then we're going to turn another. Hold up. Move forward 200, turn right 90, move forward 120, then go negative 90, I assume? Because we don't want it to turn 90. No. Yeah, we do. We want it to turn 90 again because it's moving forward and it's cutting right. We're good. Move forward 200 and then move, turn right 90, then do 120. Uh-oh. What did I do? No, I did that thing that I don't like. Is that it? There we go. Nice. Lastly, drawing a bigger rectangle. Write out calls to the function move forward and turn right to draw a rectangle with a width of 200 pixels and a height of 260 pixels. We wrote the first timelines for you. Be sure to write each instruction on a separate line. Okay, cool. So, every line should start with tab, so we know it's part of the rectangle function. Okay, thank you. Now, we need it to be 220 wide and 260 tall. So let's go ahead and do a move forward. Move forward 220. Nope, 260, because it's 260 tall. Now we're going to do a turn right 90 degrees. Then we're going to do forward. Knowing how to type makes this so much easier. It was a godsend. We need to move forward 220. And then we will need to turn right again. Another 90 degrees. And then we need to move forward 260 degrees. Well, not degrees, 260 degrees. Let's run that. Run it back. Nice. Let's keep on going. So there are a total of 27 of these lessons. I'm going to see if I can get through all of them today, because we're breezing through them right now. So yeah, let's see how many we can get through. So far, we have called existing functions that other developers wrote. In this lesson, we'll talk about what functions are and see some examples. Then you will learn how to define your own functions. Ooh, goody goody. Functions are named sequences of instructions. Functions are sequences of instructions. We give a name. We can call the name an identifier. Using the identifier, we can get the computer to execute all the instructions inside the function as many times as we need. So it becomes a code sandwich. It's like instead of asking for turkey, bacon, lettuce, tomato, and sourdough bread, you just call a BLT function, wraps all those up, and then you can ship those out. And lost where I was. In computer programming, we talk about identifiers rather than names. It's because a function's name is a label the computer uses to precisely identify and refer to a function or other code elements. Identifiers are unique. You cannot reuse the same name in a given space in your code. If you try to name two functions the same, the computer will raise an error. Well, yeah. If there is any code that you need to run multiple times, you can put it inside a function and give it a name. The instructions inside a function can be any code you want, and they will all run every time you call the function. Here's the example of move and rotate function that moves the toilet. So we named the function move and rotate, put everything inside of it. So we're creating our own function here. Move and rotate. The move and rotate function consists of two instructions, each on a separate line. Both of these functions call another similar function. Ooh, man, I was just about to say this. This thing is reading my mind. You can write another function that calls move and rotate 4 times to draw a square of length 200 pixels. I was just about to say that. So you can create one function and then create several instances of it to have it run several times in order to get a desired outcome. Every time we call move and rotate, two functions move forward 200 and turn right 90 are called in sequence. In this simple example, it may not feel super useful. Here's a more useful and realistic one, a function to draw any square. The following function uses parameters, which we will explore in the next lesson. Drag the slider to change the square size. So they set up a variable to attach to the slider so we can adjust the size. So if we set it to 200, then it's going to update that inside of all these. I'm assuming that's how I've understood it working. So let's do 20 now. Ooh, itty bitty. Parameter is a variable you create. Okay, see, I'm a bull game. You can't be tired already. We just started. How to define your own function. Let's break down how you define a function. A function definition starts with the function keyword followed by a space, the function's name, parentheses, and a colon. Okay. The instructions inside the function must all start with the leading tab character. You can insert the tab character by pressing the tab key. We call those leading tabs indents. They're important. The computer uses them to know which instructions are part of the same code. Why do we use functions? Do we use codes multiple times, to run multiple code in one go, or to put a name on multiple lines of code? All of the above. Names and codes have rules. Function identifiers cannot contain spaces. In general, name and programming languages cannot contain spaces. The computer uses spaces to detect the separation between different keywords. Instead of spaces in GDScript, we use underscores. You saw this already with functions like move forward and move local x. This is a convention we follow in GDScript. Others, I think, is in Java. I think in others, like you start out with a lowercase letter and then following you use all uppercase letters in order to differentiate them. If I'm remembering correctly, I know I've seen that somewhere. There's another convention programmers use in some other programming languages. Instead of using underscores, they start with capital letters except for the first one. With that convention, you write function names as move forward and move local. Just which of the following names are valid function names? Select all that apply. Bloop. Lap. You can mix words. No, that's not valid because it doesn't. No. No, yeah, it's fine. I think. This one should be fine. No. Yeah. This is fine. It's not? I got one wrong? What? Which of the following names are valid function names? Select all that apply. Oh, jump is too. Hold on. I'm tripping. Can you not put numbers first? Oh, wow. Where did it say that up here? I didn't read this. Identifiers also have to start with a letter or an underscore. You can't begin with a number, but you can use numbers after the first character. See, that's why we go back and read. I don't know everything. I don't know everything. Sometimes I mess up too. I can learn a lot too. Okay? Okay. You can't call a function move forward because it contains space. Names in code cannot contain spaces. They can't start with numbers either, which is why 45-degree turn is also invalid. However, having numbers elsewhere in a function, its name is fine. That's why make 3 new characters works. Instantly move the turtle to a different position. In order to draw multiple squares in different positions, we introduce a new function for a turtle to use. The jump function picks up the turtle and places it relative to where it is. So calling jump negative 150 moves the turtle by 100 pixels left and 50 pixels down without drawing any lines. Let's do that. All right. Call the function, move forward, jump, move forward, jump, move forward. Let's try this now. Ooh, we starting with nothing now. They really testing us. Code a function named draw underscore square to draw one length of one. Code a function named draw underscore square to draw one square of length 200 pixels. The function should take no parameters. Parameters are the variables, so we don't want to include that. Use the move forward and turn right function to instruct the turtle. In the following practice, you'll use the draw square function to draw multiple squares by calling your own function. Okay, so we're going to do func draw underscore square parentheses colon as the first part. Then we need to do move forward parentheses 200, right? 200 pixels. Then we need to do underscore help turn. I need to put an underscore in here. It's important. Turn right. We're gonna do 90 degrees. Then we're going to copy both of these. paste. Paste and paste. So we're gonna go forward, turn right, move forward, turn right, move forward, turn right, move forward, turn right, move forward. So we don't need this last turn right here. Let's run. Good. So now you have the function draw one square. Use it to draw 3 squares. We already created draw square for you. Create a function named draw 3 squares that calls draw square 3 times. If you just call the function, all 3 squares will overlap. To stack them diagonally, call jump 300, 300. I'll copy that now. Between 2 cells to 2 calls to draw square. Okay, let's stop it. Now we'll go down here and start another function. This one's going to be, what are we calling this again? Draw underscore 3 squares, parentheses, colon. Then we're going to start out with draw underscore square. And we're going to go on jump command and copy this 2 more times so that we get 3 squares. Jump. Jump. Nice. Breezy. Your first function parameter, we're getting the variables now. Variables are fun. In the previous part, you created a function to draw a square of a fixed size. This function is a bit limiting. Instead, it would be much better if we had a function to draw a square of any size. Or better, any kind of rectangle. A square is a specific kind of rectangle. Okay. In previous lessons, you used the rotate function to give it an argument. Arguments are the content, functions the blue. Just like rotate, we can also give our function parameters. Parameters are labels you give to values passed to the function. What? Parameters are values passed to the function. What? The rating is going to be positive. No. Okay, I said that earlier. For now, please focus on the first line function rotate radians. When you create rotate 0.5, the computer binds the value 0.5 to the label radians. Wherever the computer sees the identifier radians inside of the function, it replaces it with the value 0.5. So the parameter's name is always a label you can use to refer to a value. The value is a question, and question can be a number, text, or anything else. For now, we'll stick to numbers, as we have yet to see other value types. Okay, so then that's also important to make sure that you don't have multiple variables with the same name of radians, because then they'll overlap. Same deal with functions. What is a function parameter? A number you can make calculations, a label you give the value the function receives, and the name of the function. There we go. How to create functions with parameters. You can give your function parameters. I feel like I should read this. And calling a function. Okay. How to create functions with parameters. You can give your function parameters when writing its definition. The line starting with the function keyword. To do so, you add a name inside of the parentheses. So function draw square, and then the length is there. You can give parameters any name. How you name functions and parameters is up to you. Just remember that names cannot contain spaces. The right to write parameters names into multiple words, you need to use underscores. The following function definition is exactly equivalent to the previous one. we're gonna take a quick break real quick so I can go use the restaurant. I'll be right back. All right, we're back. Let me reset my camera real quick. There we go. So where were we? Following function definition is exactly equivalent to the previous one. So it's pretty much telling us that we can change the names if we want to. Parameters make your code easier to reuse. Here's an example with a function to draw the square. Use the slider to change the value passed to the function to draw squares of different sizes. So draw square size. Though I'm a little confused because I don't know why we're like is this parameter function specific? Is that why we can just call it size and it's good? So that's confusing me a little bit. Which is the correct syntax for a function definition? Function, no, that's just out of the way. Function name, parameter name. I like that. Function name, parameter name. Doesn't have a semicolon. And this one's missing function. So to define a function, you need to start with the func keyword, enter followed by a space, the function name, and optional parameters inside parentheses. You must end the line with the colon, which defines a new code block. We'll see moving forward the keywords other than func require a colon at the end of the line. Okay, so always finish off with the colon. It's like the period. Kind of. It's more like, yeah, it's kind of like the period to a sentence and a paragraph. We'll keep it going. Functions can have multiple parameters. You can use multiple parameters in a function. In fact, you can use as many as you need. Huh. To separate the function parameters, you need to write a comma between them. Okay. Must I write spaces between function parameters? In a function definition, you must have a space between the function keyword and the function name. However, because we use the comma to separate parameters, it doesn't matter if you use spaces between parameters. We're going to use spaces because I like it. As long as you have the comma, either syntax is correct. We often use spaces after the comma for readability. The following example defines a function that uses two parameters to move an entity on both x and y axes. Okay, so you're setting the offset x and the offset y for this function, which will be then run later by other functions to use as their arguments. Big brain, we're learning here. How should I name my function and parameters? The name of functions and parameters, oh gosh, or other things in your code are entirely up to you. They're written out by us programmers for other programmers. You want to use the names that make the most sense to you and fellow programmers. You could absolutely write a single letter name like in math classes, A, B, F. You can also write abbreviated names like POS for position or BG for background, and so on. Many programmers do either or both of the above. In GD Quest, we favor complete and explicit names. We generally try to write code that is explicit and relatively easy to read. Right now, you have to enter every letter when you code, so long names may feel inconvenient. However, this is good for learning. It trains your fingers to type precisely. Okay, so we'll keep on doing that. Then after you finish the course, you will see that the computer assists you a lot when you code. Real games with a feature called auto-completion. Based on a few characters you type, it will offer you to complete long names. When defining a function, parameters are optional. Hold on. I know we had functions before that didn't have parameters, so they're optional. There we go. You can define functions with or without parameters depending on your needs. Perfect. What's the current syntax to define a function with multiple parameters? All those except for this first one are looking good because they're supposed to go on the side of the parentheses. Function name. We got to use the comma, not just spaces. Perfect. Now it's your turn to create a function with multiple parameters, a function to draw rectangles of any size. Let's get into it. Before we create a rectangle of any size, let's first see how we can use parameters to draw simpler shapes. Here we have an incomplete function that will draw corners with lines of any length, but is missing the length parameter. Okay. Function will move the turtle forward the amount defined by the parameter length, turn 90 degrees, and move forward length pixels. Complete the draw corner function so it uses the length parameter to draw corners. Alright, so length, and length. Perfect. Though, why did it jump? That must be inside of the draw corner. Yeah, that must be inside of the draw corner thing. All right. In this practice, we'll improve our draw corner function so the angle can also vary. Add the angle parameter after the length parameter. In the draw corner function and use it to draw corners of varying edges. So let's just type in angle. Because I also need to put angle up here. Oh. I need some numbers because these radians ain't making any sense. We got 90 here and then 45 here. For why? For why? Do tell. Please. I guess it did some stuff in the background. Let's just keep it going. We want a function to draw squares of any size. We could use these squares as outlines when selecting units in a tactical game, as a frame for items in an inventory, and more. Create a function named draw square that takes one parameter, the length of the square sides. The turtle should face forward, then right when starting or completing a square. Should face towards the right. I read that one. The turtle should face towards the right when starting or completing a square. Be sure to call turn right 90 enough times in your function to do so. Okay. So we want a function draw squares of any size. Let's do funct draw underscore square parentheses. We're going to give this the attributes, or no, these are called parameters of length and angle. Finish that off with the colon. Then we're going to go down and start calling these functions. We're going to do, what was the name of it? Move forward. Move forward. Forward a length. We don't need the colon here. And then we're going to turn right the parameter angle. This is an excellent. I gotta say this real quick. Oh, that was the wrong one. This is an excellent learning tool. If any of you are trying to get into game design or coding, definitely use this. I'm a little rough around the edges because I haven't done this in a while, but like the way it explains it and has you go through the activities, I'm having a lot of fun with it. So let's keep it going. All right. So next up, so we want to make sure that it faces to the right. So right now it's moved forward, it's turned right, then we need to have this go again. So I'll just copy paste to save us some time. Boom. Now. All right. So forward, right, forward, right, forward, right, forward, right. Perfect. So I think this is good because we don't need too few arguments to draw a square. Expected at least 2. Did I not put them in correctly? Function draw square length angle. Did I not do that right? The whole class of errors has to do with the calling function with either the wrong number of arguments or the wrong kind of arguments. You need to use the error message to see what's going wrong. How to fix this? You need to either remove, add, or change the values you're trying to pass to the function to solve this issue, to know exactly how many arguments you need to check the code reference. It will show you the function definition and the mandatory arguments. So over here, what did I do? Function, draw square, length, angle. Hmm. Ah, that's what it is. I only needed to set the length because all of them are going to be 90 degrees. Let's try that. There we go. I only needed one parameter. Perfect. Oh, y'all can't see the instructions to the left. Well, you don't really need to see it because I'm reading. Or here, maybe I can drop myself down here. Open the console log. That works. All right. Let's make our square drawing function more flexible to include rectangles of varying sizes. Your job is to code a function named drawRectangle that takes two parameters, the length and the height of the rectangle. The turtle should face towards the right when starting or completing a rectangle. Note that we could still draw a square with drawRectangle by having the length and height equal to the same value. So let's come in here and go length, height. For move forward, it's going to be length. Next up is going to be height, then length, then height. Nice. Lesson complete. Stay and revisit. We're going to keep it going. Episode 7. Introduction to member variables. In this lesson, we take a first look at variables. In games, you need to keep track of many values that change over time. Player score, every character or enemy's health, the last checkpoint, and so much more. You need to store, retrieve, and update those values. We call these values variables. Variables are labels you use to keep track of values that vary over time. Here's an example of a variable tracking a character or monster's health. So variable of health equals to 100. The line above defines a new variable named health and assigns the starting variable of 100. That's what the equal sign does. More on that below. Function parameters. Okay, which you saw in the previous lesson are another example of variables. Cool. In this lesson, we start with variables built by Godot. They're a particular kind called member variables. Member variables are variables attached to a specific value type, like a vector's x and y subvariables. We also call them properties or fields of the vector. To access a member variable, you must first write the value's name followed by the access operator, period. For example, position.x. Okay, so these are specific to Godot. They won't change. We'll see it in application. Okay. Okay. The line above defines a new variable called hell. In this lesson, we start using variables built into Godot. They're particular kind member variables. Member variables are values attached to game entity. They are used for properties like the position, rotation, and scale of a character. So these can also be reused, it seems. In the previous lesson, we saw how we could use the rotate function to rotate our character. Let's run this. Okay, works how we expect it to. The function increases or decreases the value of the entity's rotation member variable. Say we want to reset the rotation to 0 and make the character upright. Using the rotate function can prove difficult. You need to know the character's exact current angle to cancel it out. It's much easier to use the member variable rather than the function. The following code assigns a value of 0 to the character's rotation, resetting its angle. Oh, okay. That's easy. Cool. Notice how we use the equal sign to change the value of the variable. So these are variables here. Got it. In video games, you will see member variables that have subvalues. For example, the position we mentioned has two coordinates, x and y. It's the same for the scale. It has x and y subvariables. They respectively control the horizontal and vertical size of a game entity. To access those x and y subcomponents, you add a dot after the variable name. So up here, okay, the code below places the entity at 200 pixels on the x-axis and 250 on the y-axis. Got it. Notice how we use the equal sign equal to assign the numbers from the right to the subvariables on the left. Unlike in maths, in computer programming, the equal sign does not mean it's equal to, it means it is. Instead, it means assign the result of the expression on the right to the variable on the left. We'll assign values so often in code that we prefer to reserve the equal sign for that. In games, the y-axis is positive going down. Note that in games, assuming your character's position starts at 0, 0, the code above moves the entity 200 pixels to the right and 250 pixels down. In math, the y-axis is generally positive, going up by convention. The convention is the opposite in video games and many computer applications. The y-axis is positive, going down. Why does the y-axis point downwards? Let's find out. This may be confusing if you only saw the y-axis pointing up in math class. However, in math, axes go in any direction. Axes. They don't even have to be perpendicular. On the computer, the position 0, 0 happens to correspond to the top left of your computer screen. Ah, that makes sense. So then positive will go down. Well, no. Negative will go down. Positive will go up. I might stop talking so much because my throat is getting worn out. This leads to another question. Why is position 0 the top left of the screen? This is due to computer and TV display history. Let's look at one last example before moving on to practice. The following code makes the character 1.5 times the starting size. Okay. There we go. How do you assess subvariables? Variables often hold subvalues, like the position has two subvariables, x and y. Why would you access the x, for example? You write a dot between the variable and the subvariable name, you write an arrow, you write slash, it's a dot. In a future lesson, we'll explain why and how those variables have subvariables. For now, just know you can use the dot to access them. We'll tell you which variable have subcomponents and what their names are. In the next lessons, you'll create your own variables and do operations on them to add or remove, score health, and name it. Score health, you name it. Okay. For now, let's practice accessing variables. Draw a rectangle of 200 by 120 pixels at the X position of 120 pixels and Y position of 100 pixels. Okay, so X position to be 120. We want the Y position to be 100. Rectangle is going to be 200 Y. X goes first and then Y goes second at 100. Nope, 120. Perfect. Draw 3 squares of size 100 by 100 that are 100 pixels apart on the horizontal axis. In other words, there should be a 100 pixel gap between 2 squares. Wow. Okay. You should draw the squares starting at the position 100 by 100. This means you should position the first square at 100 on the x-axis and 100 on the y-axis. Remember, you need to use the equal sign, equal, to change the value of a variable like the turtle's position. Write your code inside the run function so the computer can recognize it. Use the provided draw rectangle function to draw each square. So we need to draw 3 squares. First shape is 100. Shapes are 100 pixels apart. The squares are all 100 by 100. So let's do draw rectangle. Nope, don't need that. Then we're going to go and say position dot x is going to be 100 equal to 100. And then we're going to do position dot y equals 100. So that's the first step. We're setting where we're going to start the square. This means you should position the first square at 100 on the x-axis and 100 on the y-axis. Perfect. Remember, you need to use the equal sign to change. Write your code inside the run function. Use the provided draw rectangle function to draw each square. The error, the method draw rectangle isn't declared in the current class. Because I misspelled it. Let's try again. Rectangle, T-A-N-T-L-E, right? Is having some more class of errors. The calling function would be a long number of arguments, a long kind of arguments. You will need to use the error message. I'm gonna need to use a hint. Being honest. As each square is 100 pixels wide, to separate them by 100 pixels, remove the turtle by 200 pixels in total. Okay, yeah, that makes sense. You need to change the turtle's exposition for each square. Oh, Alright, I'm gonna figure this out. Oh, so do I need to define them here? Let's try that. Ah, I'm gonna close this before I see everything. So this needs to go first. Okay. So first we need, oh, because it all goes in order. So first we need to set the position. Then we need to draw the rectangle. Cut this. Then we need to jump. I'm just gonna read the solution. Ah, okay. So we just set the position, draw the rectangle, set the second position, draw the rectangle, set the third position, draw the rectangle. Okay. So, and were there any parameters inside of it? Yes, there were. So in draw rectangle, it automatically just knows what it, how big this space is supposed to be. I don't understand how it does that, but okay. So then the position X needs to be set equal to 300 so that there can be that gap. Then we need to draw a rectangle. Then we need to do position Y equals 500. Draw rectangle. 100, 100. And don't think I missed this. I see it. Now let's try. Typo. Typo. Ah, I should have set this to X, not Y. So I need to remember that everything runs in chronological order, of like literally how you want it to run out. You don't want it to draw a rectangle first because it'll just draw it wherever. If you want it to draw in a specific place, define that place first, then have it draw the rectangle, then give it the parameters for that rectangle. So I do want to experiment. What if we removed this? Nah, because that's not how this works. I couldn't use the move forward function, could I? No. We'll learn about that later, I'm sure. Yeah, because I don't think you can do the move function, move forward. All right. We're going to get to lesson 10, and then we're going to stop the stream, maybe? We'll see. I'm going to finish this today. I'm just not sure if I'll do all of it on stream. In the previous lesson, you used a predefined member variable named position. In your progress, you will need to define your own variables. So member variables are defined for you. You're going to need to define your own variables. Imagine that you need to track a player's health in your game. They may start with 5 health points. When take a hit, the health should go down to 4. After another hit, it should be 3, and so on. To keep track of that, you can create a variable named health in which you add and subtract points. The example below introduces the print function, which outputs its argument to the output box on the left. Click the run button to instantly run the entire function, and click the step button to execute lines of code one by one. The debugger panel at the bottom shows the current values of the health variable. So it's going to run the function, then it's going to, or the function is going to run the following. Variable health is set equal to 5. Health equals health subtract 1. And then you print the health. So it's taking the starting health and it's removing one. So step sets 5, takes away it, and then prints it. So prints this 4. After executing the first 2 lines of code, you will have a health variable storing a value of 4. Below we'll break down how to define new variables and explain the print function. Defining a variable. To use a variable, you must first define it so the computer registers its name. To do so, you start a line of code with the var keyword followed by your desired variable. Name, like function, stands for function. Var stands for variable. Okay. Variables are case sensitive, which means health and health are technically different variables. Be careful to use the same capitalization wherever you refer to the same variables, so you could be reading or writing to a different variable. The following line defines a health variable pointing to no value. You can think of it as creating a product label you have yet to stick onto something. So variable is health. Like with functions, a member variable's name must be unique inside a given code file. Creating 2 variables next to each other with the same name will cause an error. Okay. To use a variable, you want to assign it a starting value. You can do this by using an equal sign. The code assigns the value 100 to a new variable named health. After defining a variable, you can access its value by writing the variable's name. Function run variable health equals 100, print health. That's going to give us 100. The code above will display the number 100 to show to some output window. Notice we don't use the var keyword anymore as we only needed to define a variable. Var keyword anymore as we only need to define a variable. Once you define a variable, you can change the value anytime with the equal sign. So we changed it from, what was it, 1 earlier to 100, and then we can run the code here and it prints 50. So sets the health to 100, the health goes down to 50, and then we print the health. About the print function. The print function is generally the first function you learn in academic programming courses. It sends prints and messages. It sends prints the message or value you give it to some output window, often a black window with plain white text. Programmers often use print to quickly check the value of the variables when they run games. In the app, they made a special output window that captures calls to print and displays a card to make it friendlier for you. Here, the verb print means to send the information to display on the screen. The function prints things on your computer display. It does not relate to printers. Variables are like labels. As we hinted above, in GDScript, variables work a bit like labels. Assigning a value to a variable is like taking your label, the variable, and sticking it onto some new item, the value. Like a supermarket has a database of product labels, the computer keeps a list of all variables in your code. Given the variable name, the computer can look up the attached value. It has an important consequence. In GDScript, you can stick the label to any other value. So variable 100 health. This is some text. Print health. So that it can change it from an integer from a number to text. So we should see it print as health. Yep. Which was changed to this is some text. So first it sets it to 100, then it changes it to this is some text, and then it prints the health. The above code is like taking a label from the appropriate item and sticking it to the wrong thing. At line 2, the health variable holds a number. From line 3, health holds text. The computer will let you do that. The code syntax and grammar are correct, but it's not good. Variable names should describe the value they contain. So a health variable with a text value will confuse your future self and other coders. It can also cause errors in your game. Later on, we'll see how to avoid this issue with variable types. For now, let's practice creating variables. Let's define a health variable. Define a variable named health with starting value of so R health equals our character in our game will have health by defining the health variable. The higher the character's health, the further away the player is from losing the game. Health that changes adds tension to the game, especially if the player is fighting with low health. It's a resource that the player should manage carefully. The character's health might get low if the enemy attacks them or they fall into a hole. We can create a function to represent the damage in these cases. Function take damage, amount of damage equals health, or that means then run the next amount, which is going to be the current health variable, take away the amount. So take damage. He's dead. We pass the amount of damage the robot should take as a parameter, which is this amount right here. Line 2, subtract amount from health. Note the syntax minus equal sign, which achieves this. It's a shorthand we often use. You can also use a longer form. Both of these lines have the same effect. They both subtract the value of the amount from this health variable. Okay. So it says that health is equal to health take away amount. That's what it's saying. Interesting. You may notice that the health of the robot can go below 0. We'll see how to manage this in a future lesson using conditions. The robot's health could increase instead if the player picked up an item that heals them, or if they use a healing item. So that's what this is saying. The syntax is saying health is equal to health plus amount. Got it. So we'll heal. Here again, the condition can be go beyond 100. Oh man, I wanted to do an over 9,000 joke, but that's gonna take me a minute. Are you gonna do it, Shalani? Its power level's rising. Why am I doing this? I'm over halfway there now. I might as well finish it off. His power level, it won't stop rising. It's over 9,000. Okay, let's keep it moving. Also, once more, the short line health plus equals amount is equivalent to the longer form health equals health plus amount. Which of these would increase the health of the robot? Both of these would, right? Because this is health plus equals, so both of these only increase the health of the robot by. In the following practices, you'll code the take damage and heal functions so the robot's health can decrease and increase. In our game, the main character has a certain amount of health. When it gets hit, the health should go down by varying amount of damage. Add the take damage function so it subtracts the amount to the predefined health variable. The robot starts with 100 health and will take 50 damage. Okay. So, equals amount, and that should be good, right? It's time to heal the robot to full health. We write a function called heal that takes amount as a parameter. So now we need to function run. We're going to say amount. Then we need to no. So then we need to no, this is heal. Function heal. And then we need to say amount. And then this is going to say health plus equals to amount. Right. There we go. As we've seen, Godot has functions that do certain actions. For example, the show and hide functions change the visibility of things. We can also create our own functions to make custom effects like adding or removing health to a character. Godot also has special functions we can customize or add to. Take the process function. Process delta rotate. Okay, the process function gets its name because it does calculations on or continuous actions. It's like a juice factory that processes juice bottles. The bottles are always moving along a conveyor belt while different machines operate on them. And it's similar in Godot, but this function can run hundreds of times a second. Wow. How many parameters does the function have? 1. The process function has 1 parameter, delta. We look at it like we look at what delta is in the next lesson, as well as show how to use it. The process function won't do anything until we add something to it. You might notice the underscore in front of the function name. This is a convention programmers use to coordinate work, and it'll only make sense once you have experience coding in Godot. For now, all you need to know is that if the function exists in your code, and it's called precisely process, then Godot will automatically run it in every frame. When Godot draws on the screen, we call that a frame. Is this the same for other engines? Other engines might use different names like update. Code is called precisely process, and then Godot will automatically run it every frame. Okay. Even if the process function, why is the process function useful? It's perhaps better to see the process function in action, taking the following example. Okay. Cool. When you click the button Set Process True, you activate processing on the robot. From there, every frame, Godot turns the process function. Since we wrote rotate instruction, Godot is rotating the character by 0.5 radians many times in seconds. How often does the process run multiple times a second. The faster your computer, the more times process will run. Riddle will try to run process as quickly as it can. This makes sure any movement or animations look smooth and fluid. In the practice, you'll learn how to use the process function to rotate and move your character yourself. Alright, make the robot rotate slowly by adding to the process function. Okay, so the rotation speed is about 0.05 each frame should do. Okay, so that's process rotate function. It's going to be 0.05. That should be good. Yeah. Make the robot move in a large circle slowly by rotating it and simultaneously moving it along its X direction. To do this, add the rotate function and move local X function to process. Okay, so we want it to rotate. The rotation speed of 0.05 radians per frame, so rotate 0.05. And move the robot 5 pixels every frame. So move local X. It's going to be 5 pixels. Ah, interesting. Okay. Am I gonna keep on doing this? I don't think so. How long have we been live? Let's see. How long have we been live? Where's the thing? Okay, I'll just go to here. We've been live for an hour and a half. Do I want to keep on going further? Nah, I don't want to burn myself out. All right. Thank you very much for joining us. I'm going to keep on working through these lessons and get through the rest of them. As much as I'd love to follow along with them for everybody here, I'm kind of at my limit for talking this much. I'll improve over time, but I don't want to burn myself out first day and then not feel like coming back at it tomorrow. So I'll finish up this stuff, have some more fun, and then see y'all tomorrow. Deuces.